In the early years of manned spaceflight, NASA assembled an impressive collection of brilliant, innovative and highly motivated talent to tackle the daunting challenge of sending humans into the cosmos. They came from the military, from industry, and from institutions of higher learning. These fertile minds were responsible for some of the most impressive accomplishments in the history of mankind. The Saturn V booster, human presence on the lunar surface, and unprecedented advances in engineering, medicine and science. Today, NASA is continuing its tradition of establishing partnerships with private industry and academia for the purpose of creating innovative concepts for human space exploration. This collaborative effort resulted in the creation by a group of 7 students of a full-scale mock-up of a proposed lunar habitation module. The young space architects initially found the going tough, but quickly discovered some of the tricks to make the module more livable. One of their first initiatives was to make the area more flexible to accommodate a relatively large number of people in a small space. To achieve this, they worked from the floor up, first building a lower deck, then an upper deck. To that, they added modular units based on the existing rack system. Each of the 7 students brought a unique perspective to the design of the facility. The module represented an environment capable of supporting up to 6 crew members indefinitely. The students had to address such issues as privacy, economy of space, flexibility, and waste management. Some of the innovative design ideas included a table and seating system concealed beneath the floor, a galley, health maintenance facility, living and sleeping quarters, hygiene facilities, and a comfortable and private workstation area. After the students learned from research that one of the major problems in space was a lack of privacy at workstations, they developed a concept that linked those stations, yet kept them quite separate. Another interesting development was a sleeping area for 6 with 2 exercise racks. A key element in the architectural development was the use of computer animation to equate the theory of design with its practical application in the space environment. The students found that the moving vision gave them a valuable insight into the psychological elements of living in confined areas. And whilst the SICSA students were racking their brains for innovative ideas, University and Space Agency authorities were making their own evaluation of the program. Could a group of students from a non-traditional aerospace field like architecture come up with a workable concept for habitation facilities on the lunar surface? The answer was a resounding yes. NASA and private industry benefit from the innovative ideas and fresh perspectives these energetic young people have to offer, and also the infusion of talent that will help develop the new techniques and technologies that we must have if we are to continue our quest for the exploration of our solar system. At the Olympic Games in Athens, security was an obvious concern. So experiments were being carried out on critical applications based on the European satellite navigation program that could increase the safety around such important events. A few yards from the new Olympic Stadium, these guards need more support. With a personal digital assistant, they can send an alarm to their company's headquarters. In fact, in the control room of the security operator, snap decisions are facilitated through a clear understanding of the situation, thanks to precise positioning of the guards and even access to multimedia data providing real-time information on the problem encountered by the guards. Since he knows exactly the positions of all the specially equipped company's cars, the control manager can also send the nearest patrol team. With all the means to combat every situation, security management works very efficiently. These simulation exercises were done to show the feasibility of this project, financed by the European Union, called Instant Olympic. An info-mobility service for safety-critical applications based on integrated global satellite navigation terminals. The aim is to satisfy the needs of a case study, such as the 2004 Olympics in Greece. This project was also designed for use at sea, thus another demonstration taking place offshore of Athens. This boat simulates an engine failure, and the captain immediately calls for assistance using a dedicated waterproof handheld device. In the facilities of the boat renting company, it is easy to help using a map displaying exactly the location of the boat and receiving images from it in real time. Once again, this improves both fleet management for the company and the client's safety. These applications are possible thanks to EGNOS, the European Geostationary Navigation Overlay Service, a system that enhances the data provided by American GPS systems. It offers greater precision, less than 2 meters, and continuity of signal. EGNOS was launched by the European Space Agency, the European Commission, and Eurocontrol, and was the first step for Europe in satellite navigation, paving the way for Galileo. EGNOS allowed new services for users and improved safety in our daily lives. In the Panathinaikon Stadium of Athens, host of the ancient games 2,500 years ago, and where the first modern Olympics were held in 1896, it might have been thought that the gods were guiding events from above. Now we know that protection can come from the sky with space technology. The Russian space program began with the launch of the first satellite Sputnik on October 4, 1957, to mark the 40th anniversary of the October Socialist Revolution in 1917. The next step was the first manned flight on April 12, 1961, when Russian cosmonaut Yuri Gagarin blasted into orbit and flew around the Earth. Construction of the Mir space station was another scientific and technological achievement. The first module of the space station was launched into orbit on February 20, 1986. Less than a month later, the first crew, Leonid Kizim and Vladimir Solovyov, were making themselves at home. The designers of the space station had intended their creation to last from 3 to 5 years, but Mir's life happened to last almost 4 times longer. Mir made over 85.850 spins around Earth in the 15 years of its existence. Several international crews had worked on board Mir. On February 24, 1997, Mir had its first serious accident. A fire broke out when cosmonauts tried to change an air filter. The 6 cosmonauts on board at the time, from Russia, France and the United States, had to wear gas masks for a time. Several months later, a Progress cargo ship hit Mir during docking, puncturing one of its modules and damaging solar batteries. In September 97, a computer failure sent Mir spinning out of orientation from the Sun, and it was a nervous 24 hours before Mission Control regained control. This series of failures signaled that the aging space station might not be safe enough to use any longer. On June 9, 1998, the last US astronaut left Mir, ending US-Russian cooperation on their orbiting outpost. The last crew left Mir August 1999, after which the station's main computer was shut down and Mir went into hibernation while Russia's space authorities tried desperately to find money for a new manned flight.
The hope for the Mir space station came from the US. Some investors pledged to pay $20 million to continue the Mir program. A month later, a cargo spacecraft delivered fuel and supplies to restart the space laboratory. And shortly after, a two-man crew returned to the space station to adapt it for tasks ranging from industrial production and scientific experiments to space tourism and advertising in orbit. But all efforts to prolong Mir's life came to nothing. Equipment failures continued, and promised private investment failed to materialize. On November 16, 2000, Russian space authorities finally decided to dump Mir in the Pacific Ocean. The Russian Space Agency head, Yuri Koptev, said that irreversible processes had started on board of the station. Almost all its modules were out of order. The replacement of the basic section would cost $300 to $350 million and take 4 years. The height of Mir's orbit was less than 250 kilometers, and the station was falling 1 kilometer lower every day. According to Koptev, restoring Mir would cost more than building a new station. But these arguments were not convincing enough to many Russians who strongly opposed the sinking of Mir. One of them was former space station cosmonaut Vladimir Titov. But despite his protests, the sinking of Mir, once the symbol of Russia's space glory, was inevitable. It splashed into the Pacific on March 23, 2001, going out in a spectacular blaze of glory.
In 1983, NASA was set to launch a new satellite that would be able to observe the heavenly bodies in infrared. IRAS, as it was called, was an international project. The heart of the new Earth-orbiting satellite was a highly sophisticated infrared telescope, supercooled to 455 degrees below zero, which gave it unprecedented sensitivity to celestial infrared radiation. IRAS was launched into orbit above the Earth's atmosphere by a Delta rocket. Over the course of its 7-month mission, IRAS scanned the skies with our different infrared wavelengths, detecting almost 1 million celestial phenomena that are invisible to our eyes, but glow in the infrared. One such phenomenon is the birth of and death of stars formed from dust clouds. And as low-temperature dust gives off infrared, these unusual stars became easier to detect and track than ever before. The process also worked on stars that had already collapsed and cooled millions of years ago. The Infrared Astronomical Satellite looked at the stars in another light and helped astronomers to better understand the evolution of the universe. This is Pioneer 10, a 570-pound spacecraft that was destined to become history's most distant human-made object and the first to leave our solar system. Pioneer became so distant that at the speed of light, its radio signal took 15 hours to cover the 10 billion miles from Earth to the spacecraft and back again. The spacecraft carries 11 instruments that have been used to measure magnetic fields, solar wind, high-energy cosmic rays, cosmic and asteroidal dust, and Jupiter's ultraviolet and infrared radiation. In March 1972, NASA launched the Pioneer 10 spacecraft from Cape Canaveral for a 21-month mission to study the giant planet of Jupiter. The hardy spacecraft accomplished more than 2 decades of exploration, returning data that characterized the solar system while passing the orbits of every known planet around the Sun. In 1983, the spacecraft left the planets behind, 2.8 billion miles from the Sun. Now 6 billion miles from Earth, Pioneer 10 continues to provide data for research. Even in its final days, more than a quarter of a century after its usual lifespan was expected to expire. Pioneer 10 became the first spacecraft to reach Jupiter, the first to use a planet's gravity to increase its velocity, the first spacecraft to come the closest to Jupiter, and the first to exit the orbits of the known planets in the solar system. Navigating the asteroid belt between Mars and Jupiter and overcoming Jupiter's radiation environment were considered Pioneer's biggest challenges. Scientists were concerned that the belt of dust and rocks might pummel Pioneer 10 at thousands of miles per hour and destroy the craft. Instead, Pioneer emerged nearly unblemished from both the planet's radiation and the asteroid belt. Now Pioneer 10 is continuing to record the intensity of galactic cosmic rays in the outer heliosphere, the region of solar wind influence, and searching for the heliopause, where the flow of hot gas from the Sun comes to a rest as it bumps into the interstellar medium. Pioneer 10 paved the way for future space travel beyond the inner planets as it flew by Jupiter in 1973. Pioneer carries a plaque with an engraved message to extraterrestrials about its home planet. Pioneer will approach 10 stars over the next million years. The closest approach to any star system will be in about 30,000 years. Because the emptiness of interstellar space offers a non-destructive environment to the spacecraft, Pioneer will probably still be travelling amongst the stars when the Sun becomes a red giant and destroys the Earth in 5 billion years. Pioneer is so far from the Earth that its radio signal, equivalent to the power of a nightlight, takes 9 hours and 10 minutes to reach Earth. Her faint signal will continue to provide a radio beacon that can be used by the Deep Space Network and other facilities. It can also be used to benefit Lunar Prospector, the Discovery mission that will inherit the Pioneer Operations Center. Travelling at about 28,900 miles per hour, Pioneer continues its lonely journey into deep space, providing even more information about our unknown frontiers. This is Gemini 3, the first of the manned Gemini missions back in the 60s, the earliest days of manned space exploration. The total of 12 Gemini missions had several main objectives, including the investigation of long-duration space travel, extravehicular capability, re-entry flight path control, and the conduction of scientific experiments. Gemini 3 completed 3 successful orbits on March 23, 1965, which marked the beginning of 19 months of manned space accomplishments. The long-duration investigations were crucial to future space travel, because if man could not tolerate extended periods in zero gravity, extended space travel may have remained in the realms of imagination. Long-duration flights tested the endurance of both spacecraft and crew. On the spacecraft side, Gemini 5 was powered by fuel cells for the first time. They replaced conventional batteries. Fuel cells were also used successfully on all missions from 7 through 12. This was important because batteries were inadequate for many future space missions at the power levels needed. Apollo, for example, would use similar fuel cells. Medical aspects of the flight were closely studied for such everyday matters as the ability to eat and sleep in space. When astronauts Gorman and Lovell completed 14 days in Gemini 7, it offered much-needed data. Planners then knew they could medically commit crews for flights of up to 30 days. This footage shows the first rendezvous between two spacecraft ever, as Gemini 6A comes within a foot of Gemini 7 while in orbit. At the 11th rendezvous on Gemini 12, this photograph of a solar eclipse was taken. For those who followed the flights from the sidelines by listening to reports on television, rendezvous seemed almost like an automatic exercise. But simply because it was done well did not mean that it was easy to do. Rendezvous required 3 years of theoretical preparation, integrating space mathematics into the constraints of the mission and its hardware. Approximately 100,000 hours were spent on computer computations. When crews were assigned to specific rendezvous flights, each primary and backup crew trained for approximately 400 hours in flight simulators, a total of almost 5,000 hours of rendezvous simulation. Gemini 9A gave NASA its first sophisticated rendezvous experience. 3 different approaches were completed within 24 hours, each of a different nature, to test the practical execution of what was until then all theory. A dual rendezvous was performed between Gemini 10 and the Agena 8, a passive target vehicle still in orbit from an earlier launch. Gemini 11 achieved what is known as a rendezvous in the first orbit, a rendezvous that was practiced in the event of a lunar approach abort. During the first rendezvous, Gemini 6A had moved to within a foot of Gemini 7, but of course the two could not dock. The first space dock came in March 1966. The spacecraft was Gemini 8. Astronaut Armstrong moved in very slowly while making his final approach until he was about 3 feet from the target. He then held his position. Once docked, the Gemini Agena configuration stayed stable for almost 30 minutes. Gemini completed 9 successful dockings, most of them performed in the final 2 missions, 11 and 12. In short, with Gemini we learned we could assemble an orbital workshop and conduct scientific experiments in it for extended periods of time. In the early years of manned spaceflight, NASA assembled an impressive collection of brilliant, innovative and highly motivated talent to tackle the daunting challenge of sending humans into the cosmos. They came from the military, from industry, and from institutions of higher learning. These fertile minds were responsible for some of the most impressive accomplishments in the history. creation by a group of 7 students of a full-scale mock-up of the proposed lunar habitation module. The young space architects initially found the going tough, but quickly discovered some of the tricks to make the module more livable. One of their first initiatives was to make the area more flexible to accommodate a relatively large number of people in a small space, free of mankind. The Saturn V booster, human presence on the lunar surface, and unprecedented advances in engineering, medicine and science. Today, NASA is continuing its tradition of establishing partnerships with private industry and academia for the purpose of creating innovative concepts for human space exploration. This collaborative effort resulted in To achieve this, they worked from the floor up, first building a lower deck, then an upper deck. To that, they added modular units based on the existing rack system. Each of the 7 students brought a unique perspective to the design of the